Hello, this is the first part of 1.4 from the Pearson Algebra 2 book. We're just going to be solving some linear equations. They're going to be kind of nasty, some of them, frankly, with some fractions, some multi-steps, some distribution. So we have all different kinds we're going to have to be masters of. I know you did a lot of this in Algebra 1. We're just going to kind of beef it up here in Algebra 2, but let's start with the basics. So we're going to be first solving some algebraic equations when there's just variables on one side of the equation. So really like you to think about, because this has an equal sign in between the two expressions, that we have two sides of the equal sign. And if I'm trying to move across the equation line, that means I have to do opposite operations. It's kind of like a balance scale. So the idea is to get the variables isolated by themselves. So right here on this side, 4x is the only variable. Let's keep him where he is. But the positive 7, I'm going to have to move to the other side. So opposite operation for adding 7 would be to subtract 7. To keep your scale balanced, you have to do it to both sides of your equation. And that leaves us with 4x equals 20. And then our next step is to isolate the x, because it's currently being multiplied by 4. So the opposite operation to multiply by 4 would be to divide by 4. Keep your scale balanced, divide by 4 on both sides, and x equals 5 is our solution. So I know you're tempted to go faster, feel less work. Go away from that habit, especially the way we're grading here in Algebra 2. I want to see all your work. I want to be able to tell you where mistakes are happening and give you a lot of feedback. There's a couple of ways you could approach number 2. 5 divided by 2 times x equals 20. So x is being multiplied by 5. It's also being divided by 2. You can get rid of those two operations either separately or at the same time. And I'm a big fan of being lazy smart, so let's do them at the same time. So instead of multiplying by 5 over 2, what if I multiplied by their reciprocal, which is 2 over 5? And that would be the opposite operation of 5 over 2, multiplication. But remember the scale, I got to keep it balanced, right? So these cancel each other, and you just get x on the one side of the equation line, and then 20 times 2 but divided by 5. You could do those in either order. I like to divide first, so 20 divided by 5 is 4, times 2 is 8. Again, no harm in using your calculator for those, but you want to try to do a little mental math before you reach for the calculator. Test yourself. Now, there's no way I'm going to ask you something that easy, guys. This is Algebra 2. So what happens when we have variables on both sides? Well, your job is to collect all the variables to one side of the equation line and all the constants to the opposite side. So it's up to you what side you want to bring the variables to. I've noticed most children prefer to bring the variables to the side that keeps the variables coefficient positive. So most of you would decide to move this 3a over here through subtraction. So we just have a 13 now equals, this is now a 6a minus 8. So if you choose to bring the a's to the right, constants have to move to the left. So we would have to add this 8, opposite operation. Whoop, quickly. 21 equals 6a. And then we're going to divide both sides by 6. And I know you're really tempted to leave your answer as 21 over 6, me too. But 20 over 6 does reduce. They're both divisible by 3. So that reduces to 7 over 2. You could either manually reduce that in your noggin, or you could take your calculator, type 21 divided by 6, and then hit math, enter. Now, me personally, it is Monday night. I am very tired. I put my kids to bed, and I'm exhausted. So I'm not feeling too mentally capable at the moment. So if I make a mistake, I apologize in advance. Here we have some distribution that we're going to have to simplify, and we're going to have like terms to collect. Holy cow. And then we have to worry about moving to the other side. So this distribution set becomes a negative 12x plus 4. Then they thought they'd get kind of tricky over here. We have a negative 10 times x minus 4, so that becomes a negative 10x, and then a plus 40. And then they got really sneaky and snuck in another term of negative 14x. So this is going to get exciting. Before I start worrying about what sides to collect my variables to, you got to clean up the sides themselves. I notice on the left side, I don't have any like terms on the left side, but on the right side, look at this. I got some like terms right there. So if I smush the negative 10x and the negative 14x together into one common term, that's a negative 24x. The plus 40 hasn't done anything yet. And now I can make a more informed decision as to how I want to proceed. So, like I said, most of you like to keep your coefficients positive on your variables, so most of you would decide to add this 24x yonder. And then I'll show you a bit of a shortcut. If you're adding the x's to the left side, you can go ahead and simultaneously move the constant to the right side. All in the same line. It's kind of fun. Because look, just cancel. All right, so carefully simplify here. We have 12x. Usually when I start warning you about being careful, this is where I make a mistake. So, warning, divide by 12, divide by 12. X equals 3. Didn't lose a negative there, Bruzo. All right, so equations, we love them. They're wonderful. We love solving them. We did like a gazillion of these in algebra. You probably did a gazillion in geometry. The thing about equation solving is it can get real complicated. I mean, that particular question we just did, 1, 2, 3, 4, 5, 6, 7, 8 different places I could have messed up. So we have to kind of go slow, be deliberate in our work, and show our work. Oh man, now if you do not like fractions, this is your worst nightmare, because this is fractions everywhere. So what if I told you I too, not a fan of fractions as far as algebraic work goes? So what happens is I can actually, because it's an equation, I can get rid of all the fractions. I can make this so it doesn't have any fractions in the work. I might still have a fraction answer, but I don't care once I get to that step. What we're going to do is we're going to multiply by a least common, they said denominator here, but what you're going to do is you're going to look at the denominators and look for a least common multiple. It's the same idea. Ooh. It's the same idea as finding a least common denominator, but what's kind of cool about this method is it doesn't have to even be the least common multiple. It could be any common multiple. So when I look at my denominators here, I have a 1, a 6, and a 12. So I'm looking for a multiple of, forget the 1 because he's everybody's multiple, but a 6 and a 12. And what some kids do is they just have no clue, right? So you can, in theory, just multiply them together. That's 72, and that's a pretty big number, but you know what's cool? It's still going to get you the right answer. I'll show you a trick on your calculator. Your calculator has a least common multiple tool. It's under the math menu, so if you press math. Okay, Bruzo, come on, math. Delete. Sorry, I had my ink. All right, math, and then go over to number. There's like multi-menus within the menu, and then down to number 8 here. It says LCM, and then I typed 6, comma, right here, and 12. Your calculator will tell you what is the least possible number that is a common multiple of 6 and 12. Turns out it's 12. Now, if I stopped and thought about that for a little bit more time, I probably would have been like, oh yeah, 12. So what we're going to do now is we're going to multiply every single term in this equation by a 12. I know this feels like a lot of work, but you're going to need to utilize this technique later. So make sure you learn it now when it's nice and easy. So 12 times x is 12x. Now this is where you can either do some mental math or some calculator math. When you do 12 times 5 over 6, there's a bunch of ways you could do that. You could literally type 12 times 5 divided by 6 on your calculator and you will get 10. That's fine. You could do 12 times 5, which is 60, divided by 6, which is 10. The other thing you can do is this is the way I do it, because sometimes I don't have a calculator, is I do the division first. 12 divided by 6 is 2. 2 times 5 is 10. So that's how I'm going to come up with this next term, which is minus 10. My theory on doing the division first is that if I knock my number smaller, it's easier for me to do mentally. So I always do the division first. The same thing here. 12 times, 2 divided by 12. Again, I'm going to do the division first. 12 divided by 12 is 1. 1 times 2 is 2. Oh my gosh, look at that baby equation. I could have done that like a bunch of years ago. All right, so let's add the 10, and then divide by 12, divide by 12. Turns out x equals 1. And I know some of you are going, oh, Bruzo, that was a really weird way to do that equation. I already figured it out. I just kept the fractions. I used my calculator. Life was good. Bravo to you. However, this technique is going to be utilized later on in our course where you have to use this technique. So let's do it now and practice it and become master ninja warriors of the LCM method. So that way when we get to the rational functions unit, you won't want to cry. All right, so let's look at our denominators. 4, 5, 2, and then another 4. So you just have to figure out a number that's big enough to knock out a 4 and a 5 and a 2. So if we were doing this live in class, I would have some eager children shouting out the answers and frustrating all of your neighbors. So pause and think to yourself a number that would be big enough to knock out a 4 and a 5 and a 2. And you got to remember 5 is kind of the stickler there, so it's got to be one of the multiples of 5. And you go, oh, 20 will work. So 20 is the least common multiple for 4, 5, and 2. So let's have fun with the LCM method. So here, again, I like to do the division first. So 20 divided by 4, that's 5, times 3 is 15. So 15x is the first term. So what I did there is I went 20 divided by 4, 5 times 3. All right, so now I'm doing 20. I'm going to divide by 5 first, so that's 4. 4 times 3 is 12. And obviously I do this in my head. I don't write down a bunch of chicken scratch all over. So 20 times 5 over 2. If you're not digging this method, guys, doing it in your head, I understand. I totally get it. If it comes down to a summative and you're just freaking out that you don't think you're going to be able to do this, just use your calculator. Just type literally 20 times 5 divided by 2 and you'll get the right answer. Plus 20 divided by 4 times 1 would be a 5. All right, now for the fun part. To solve our equation, it's up to you where you bring your variables, but I'm going to go with the majority and bring my x's to the right so they stay positive, which means I'm going to bring my constants to the left at the same time. Knocking out these guys. Notice the separation. Big mistake that happens from some Algebra 2 kids is they start bringing everything to one side of the equation. When you're just, oh, look what I did. Crossed off the wrong thing. You are not gone. So think about, are you bringing your variable term and your constant term to the same side? If you're doing that, you're going to get what kind of looks like the right answer, but it's going to look like a little different, and you're going to think, oh, I'm close. No, you're really, really super wrong. So don't do that. We're going to talk more about our grading system here in Algebra 2, but when you bring all of your terms to one side of the equation line, you're making a very large conceptual mistake, and that's a very low score if you keep doing that. So watch out for that. All right, now 7 is like superpower problem because it's got parentheses distribution of fractions, and then we still have fractions, but like I can't really understand what I'm working with quite yet. So what I would like to do is go ahead and take care of this distribution. I'll just deal with it. 3/4 times 4/5. You could literally type 3 divided by 4 times 4 divided by 5, or you could remember a little 5th grade math here, guys. The 4s are going to cross cancel and give you a 3/5 x minus. Same thing with the 3/4 times 2. You could literally type 3/4 times 2. It is a fraction, so hit math enter, enter. Or you could cross cancel this a little bit. So 2 over 4 becomes a 1 over 2. Don't get hung up with the fractions with me right now, guys. Just really, if you're so scared of the fractions that you don't even want to do the little kid math with it, I understand. Just use your calculator for now. All right, this I can work with. 5, 2, and 4. Aren't those the exact same denominators we just worked with in the last problem? So 20 is going to be a nice LCM for those. So multiplying a 20 into every single term of this equation. 20 divided by 5, 4, times 3 is 12, x. 20 divided by 2 is 10 times 3 is minus 30. 20 divided by 4 is 5, times 11 is 55. Okay. And add 30. Now, I know a lot of kids out there are thinking, gosh, math teachers, they get so angry about kids showing their work. Like, what if I don't have to show my work? Your work is a communication device between you and me. So when we're grading summatives, and I'm as guilty as the next person, I make some really weird mistakes. Like, I clearly know what I'm doing most of the time. But man, I'm talking, I'm writing, like my hand and my brain aren't agreeing, or I'm going too fast, or like I anticipate the answer and I write down the answer before I get to the answer step. So if I don't show my work to my teacher, she can't kind of follow my brain logic there, and she can't give me feedback on what is wrong. If I just have a wrong answer, there's no communication whatsoever. Your teacher can't help you grow. You can't help yourself grow. So showing work is never a bad idea. I know sometimes in timed events, like an SAT test, you feel like you're going to run out of time if you show all of your work. You don't have time to do that. You have to kind of remember the sacrifice between showing work and being accurate in your end result. For most kids, the less work they show, the more inaccurate they are. And it's not because they don't know what they're doing, because they're just a little sloppy. All right, so hey, proportions. Remember these guys? So you probably learned a very acute technique of cross multiplication. Probably, oh gosh, pre-algebra maybe? We're going to learn later on in the semester why cross multiplication actually works. But for now, let's just remember what it means. You take the, woo, yuck, diagonal, and you multiply them together. So this numerator times this denominator, which again, don't encourage you to ever skipping steps because it's not good communication, right? And then this numerator times this denominator. And what we end up with is a nice linear equation that after a few distribution steps, we're going to be able to solve. So 4x minus 12 equals 6x plus 12. Don't get scared of the 12. They aren't going to cancel out here. So I'm going to follow the majority here and bring my x's to the right, which means my constants are going to go to the left. See if I can do it right this time and cross off the correct thing. Yeah, almost did it again. All right, negative 12 minus another 12, careful, is negative 24, not 0, equals 2x. And then you'd be surprised how many kids mess up right here because they're going a little fast. They have what I call upside down dyslexia. They divide totally backwards because, we got a little bit of dyslexia. I also suffer from this. Negative 24 divided by 2 is negative 12. The only way to kind of stop doing the upside down division that's incorrect is to show your division step and also just stop and concentrate. If you find that you keep making the same mistake over and over and over again, a little bit of self-awareness will surely help you. So we all love proportions. They're nice and easy for us to solve once we know what to do. On number 9, it almost looks like a proportion, right? If only it was like a singular fraction on the side. So what if you went ahead and just kind of did that? That's what I love about algebra. There's some rules you have to follow because of like the logic of it and the balance of the scale, if you will. But you could pretty much do anything you want as long as you follow those rules, right? So this is a fraction. It's like 9 over 1. So if we were to cross multiply, which some kids just view this as multiplying by negative 5 over here, that's fine. That's essentially what you're doing. So we have negative 2x plus 10 times 1, which is just negative 2x plus 10. And then negative 5 times 4 is negative 45. Now I can solve that. A little bit of concentration and I can get this right. Minus 10. And then I divide. See, I learned my lesson from my dyslexia. So look how much division I'm showing, right? X equals reduced improper fractions, always, always, always for algebra 2, unless it otherwise specifies, or if you're doing an application, which is fancy talk for a word problem, and like it doesn't make sense to give a fraction answer. Like for instance, like, gosh, like how much change did you give the person? Like I wouldn't be like, oh, 7/12 of a quarter. Like that doesn't make any sense. So that really doesn't make sense. So don't do that. So linear equations, we love all of them, but what about setting them up? And story problems, we learned on the last lesson that, the word examples I give you might be pretty lame, just to illustrate like a very basic problem for a very important topic. Trust me, these will get more complicated eventually, but for now, they're going to not look very complicated. So we have a base salary for a real estate broker of $18,000, and then she's going to get 4% commission on all of her sales. So how much must she sell in order to earn $55,000? So a little bit of a verbal model here I think might help us, especially if you don't really know what a real estate broker is. So this person's going to make money on how many real estate deals they can administer. So they're going to get $18,000 no matter what. So their total pay is going to be comprised of her base salary, which I know we know numbers, just avoid the numbers for now. But then she's also going to get commission on her sales. So she's going to get a certain percent that we're going to multiply by all of her sales. So that's going to be our verbal model. Let's start plugging in numbers now if we know them. So total pay, I want it to come out to $55,000. My base salary is $18,000, I know that. My percentage is 4%. Remember, you got to write algebra percentages as decimal versions. And then the sales, isn't that like the whole point of this question? So that is my variable. I'm going to leave it as x. If I go to solve this equation, I'm going to subtract the 18,000. Oh boy. Let's see, 437,000 equals 0.04x. And then we're going to divide both sides by 0.04. Now, before I type this in my calculator, let's think about like an appropriate answer. We are talking about how much real estate this person is going to sell throughout the year. So real estate is like properties and houses. So if I get an answer of like $1,000, like that, that doesn't make any sense. I wouldn't sell like $1,000 of a house and be like, yep, I'm good. Let's see. Oh boy, $925,000. So that, my friends, makes more of an appropriate answer. She's going to sell $925,000 worth of real estate property this whole year. So, you know, a house is roughly 100,000, you know, depending on where we're looking, how big of a house. So she's got to sell or broker like 9 deals this year. That makes sense. All right, you have a summer job. Oh boy, I should have updated this question. $5.60 an hour. That is not good. All right, so let's say you get $8.40 if you start working overtime, but that's only for the overtime hours, right? How much overtime must you work in order to earn a total pay of $287? So again, a verbal model might help us here. So our total pay is going to be calculated by, we're going to have regular hours that we're going to get paid regular pay for. But then, if we work overtime, all those overtime hours are going to get overtime pay. Overtime's awesome, isn't it? So let's start plugging in numbers. I know I want 287 here. And I know it didn't outright tell you this, but regular hours that was given to you, regular hours would be 40 hours. We're going to multiply that by 560. And then overtime hours, I do not know, but overtime pay is 840. So 8.4 times X, or X times 8.4, same thing. I don't know what this number is, but I'm going to need to type that in. Oh, 224. We got 287 equals 224 plus 8.4x. Whew. Hello, 24. Let's see. 63 equals 8.4x. You know, almost isn't seeming worth it. 7.5 hours. Yuck. This poor kid needs to work almost 8 hours of overtime this week, or this pay or check or whatever. Oh boy. Oh, all right, one more. A new iPad was recently purchased in Algonquin for $464.40, including tax. If the tax rate is 8%, find the price before taxes. Now, this was a multiple choice question. We can kind of work backwards to find the answer, but we don't have that luxury this time. So what's happening here is when you have a total price, we'll call it, what the cash register does is it takes the sale price or the sticker price or whatever you want to call it, but then it also has to incorporate tax, right? So it's going to take the sale price again, and multiply it by the tax rate. There's a few different ways it could calculate this. Another way to do this would be to say it is the sale price times 1 plus the tax rate. And if you think about that, that kind of makes sense, right? Like if you're tacking on 8%, 1 plus 8% would be 108%, like 1.08. So either way, this works out great. So the total price I know is $464.40. And then obviously this equation is a little easier, right? So if I call the sale price like, I don't know, and then I say 1 plus the tax rate, which is 0.08. Little simplification here, guys. 1 plus 0.08 is 1.08. So if we're going to divide by 1.08 here, we're going to get an answer of, I don't even know. I'm so tired. $464.40 divided by 1.08, $430. Now, you want to kind of stop and think to yourself, oh, does that make sense? They were asking me for the price of the iPad before they tacked on all that tax. $430 was the sale price. That makes sense. All right. So the good news, the fun is not over. 1.4 part 2 is going to be our next lesson, and that's going to be isolating for variables inside of linear equations. It's going to be a good time. Meet you up.